Hi and welcome to Concept Based. I'm John Hepworth. This question looks pretty benign. Calculate the exact value of tan pi on 3. We've done some exact values of trig ratios and we seem like we're completely across that, except there's this weird pi on 3 thing that's in there instead of being some angle that we're used to like 30, 45, 60 or some multiple of that. And the reason why it's pi on 3 in there is because it's actually written as a radian, not as a degree. Now, this doesn't actually come off your year 10 mathematics work because even up into Trigonometry D in the path section, there is no reference of radians. In fact, if you go into the year 10 syllabus and you type in the glossary radians, there is no definition. So you haven't actually seen radians before in year 9 or 10. So this is a completely new concept. So let's delve into what this concept is. What I've done is I've created a little bit of a GeoGebra piece here to try and describe what's going on. So first of all, what I want to do is just talk about, well, what is a degree? Like what is an angle? How do we have that? Well, we're used to that, right? We come to this definition that that's not what I want to drag. This is what I want to drag. We've come to the definition that there's 360 degrees in a circle. Now that's just arbitrary, right? That's just a number. We could have picked that it's some sort of decimal situation. Maybe we could have made 100 degrees in a circle or 1,000 degrees in a circle. And then a millidegree would be 1,000th of a circle. That could have been an option. But we have this 360 degree unit that we currently use. But the idea is for radians is that the unit is inherent to the information in the circle itself. It's not picked from some arbitrary value that we apply to it, but it's inherent in the circle. So the question is well, how can it be inherent in the circle? What can we use in the circle to try and define something? Well, let's look at the circle. We've got a radius, and then what we do when we make an angle in the circle is we actually create an arc length. And so the idea for defining what a radian was, or is that if you go and take whatever radius you've got, I'm just setting it as a unit circle at the moment, easiest to work with, and we then go and span out an arc of that radius. So in this case, the arc would need to be 1 unit long because I'm in a 1 unit circle. We've now laid one lot of the radius onto the circle to make that arc. And this is actually the definition of what a radian is. So I'm in GeoGebra here, and if I go into settings, and that's not the settings, if I go into these settings, these global settings, and I change the angle unit from degrees to radians, and then close that down, there's a rounding error. We can see that we have 1 radian for 1 arc length of size 1 radius. So this defines radians for us. Okay, great. Radians are now defined. We have what the size of 1 radian is, but the problem is that we're getting asked a question that looks like this. Tan equals pi on 3. So where does pi come from now if these are the questions we're being asked? Well, we still want to look at particular angles that we've looked at before, 30, 45, 60, and so forth. So we need to be able to break down the circle into those sections. So then the question is well, how many radians are actually in a circle? So if we take our radians and we spin them all the way around, let's have a think of what we've done. We've created an arc length that is the circumference of the circle. So how big is the circumference of a circle? Well, twinkle, twinkle, little star, circumference equals 2 pi r, 2 pi lots of the radius. Now, this is in a unit circle, so therefore, the size of the circle is 2 pi, and therefore we're talking about 2 pi radians. So a complete circle or a complete circle of angle in radians is equal to 2 pi. Okay, so let's go back to our working out and see what we can do about working with that. So we now know that 360 degrees is equal to 2 pi radians. Okay, I'm just going to write rad here. 2 pi radians. There is certain indicators that we can say are radians, a little c is sometimes used, but often it's just written as radians. I'm writing it just as rad here. So the question then is, well, how do we convert between these two? Well, the idea is that you use the unitary method. So if I wanted to go down to 1 degree, I would divide both sides by 360. And I'm going to get that 1 degree equals, now the 2 cancels with this 360 to 180, and we get pi on 180 radians, right? That is what 1 degree would be. So we have this conversion, this pi on 180 idea. Now, if I would have gone the other way and I would have tried to find out, well, what's 1 radian, then I would have been doing the opposite of dividing by 360. I would have been dividing by 2 pi. And that's going to get me to cancel down to 1 radian. And now we're going to do the same thing. The 2 cancels the 360, and we're left with 180 on pi. So essentially, the unit of conversion that we have, or the conversion we have, is 180 on pi, or pi on 180. And we use those conversions to convert between radians and degrees, so that we can use them in whatever method that we wanted to use them. So let's look at this situation, tan pi on 3. Okay, so we have pi on 3 radians. And we want to try and convert that to how many degrees that we would have. So we said before that 1 radian, we divided by 2 pi, we ended up with 180 on pi degrees. So if we want to know how many degrees this would be, we would multiply this by 180 on pi. So times 180 on pi, the pi's are going to cancel. We often don't see pi in our degrees. And 180 divided by 3 is 60 degrees. So pi on 3 converts to 60 degrees by using this conversion tool, this times by 180 on pi, or if we're going the other way from degrees to radians, would divide by 180 on pi, or times by pi on 180, because obviously they are the inverse of each other. So therefore, we've got it into this 60 degree calculation now. This is obviously helping us for this question. Now, what I want to do just before we go and actually do this question is I want to draw out to you a little bit of a note on the fact that on your, oh, actually, no, this is not where I put it. I put it down in our OneNote. If we have a look at the formula sheet for the advanced mathematics course, now I'm not talking to current year 12 students in case you're doing revision. This formula sheet comes active in 2027, the one I'm referring to. If you look at it in the trigonometric functions section, you can see here that the exact value triangles are in degrees. But there are even some formulas down in here that are actually referring to radian formulas, but nowhere in this whole section do we see any sort of conversion of pi over 180 or 180 over pi. So that's something you're going to have to recall, you're going to have to remember, and you have to retain, which there is a bunch of things in maths you have to retain. So when something is a thing that you have to retain, I always try and make sure that I understand why it is what it is. So at the very least, when you're trying to retain this, try and remember 360 degrees equals 2 pi because it's the circumference, and work from there. And then you'll always be able to get back to this conversion factor of 180 on pi or pi on 180. Or if you can just remember it, that would save plenty of time and you'll be able to do these conversions. Okay, so here we've found that our conversion for pi on 3 refers to 60. There are actually a few more that are out there. So pi on 3 equals 60 degrees. Pi on 4. So let's think about it. If we're chopping down essentially, in this case, not 2 pi, but half a circle got chopped in 3 parts. That was 60. Well, in this one, pi, half of the circle is going to get chopped in 4 parts. So that's going to get us 45 degrees. And then there's one more that we generally use, which is pi on 6. And if we took half a circle and chopped it into 6 parts, we would end up with 30 degrees. So these are your standard basic conversions of units between between radians and degrees. And then you're just looking at multiples of them. So you'll often see like 4 pi on 3 or 5 pi on 3, multiples of 60 degrees or something like that, or multiples of 30 degrees. You might see 5 pi on 6. And so you're like, oh, that's 150 degrees because it's 5 lots of that pi on 6 conversion. So if you get all of these ones down pat, then you just know that they're multiples of those things and you can recall those in the test. And again, that will be super fast if you can remember the basic forms. And these are the basic forms because they relate to our exact value triangles, which as you saw are on the formula sheet. But we want to remember those as well. So in this question, let's make this question a bit more visible. What are we going to do? How are we ever going to attack this question? Well, really, there's 2 ways. One is understanding, another one is we're going to use our calculator. So we'll do the understanding way first. Otherwise, I've just wasted all this time explaining this content. So we now know that pi on 3 is 60 degrees. We know that 60 degrees relates to the exact value triangle that has 60, 30 in it. And we know on the exact value triangle that the 60-30 triangle is a 2-1 root 3 triangle. And if I'm looking for tan, I'm looking for opposite over adjacent. So I'm looking for root 3 on 1. So for tan 60 or tan pi on 3. So the answer to this question, tan pi on 3 is equal to root 3 on 1. Or just root 3. Okay, question solved. But that's only half of the discussion, because there's a whole other part of this discussion is, well, why aren't you just using a calculator? Of course you can. So with just using calculators, we have to take into consideration one thing that we can make a mistake on. So going back to our other window, I've not just got a GeoGebra thing set up, I've got the Desmos calculator set up. So here's the Desmos calculator, and you'll see down in the bottom here, there are these 2 buttons, rad and deg. Now, whatever calculator you're using, they also are going to have rad and deg on them. I use a Casio FX82AU Plus, again, not sponsored. And I'd love if I could use an emulator on the screen for this, but I'm not sure how Casio feel about that. So on here, on my Casio, I can actually go and change degrees and radians in the setup section. So, you know, shift mode, so setup, and then it says deg, rad, and gra, G-R-A. So I can switch between degrees and radians. Now, this can actually cause a problem for students because you might forget to switch between them in the HSC and you end up making a mistake because you've got your calculator in the wrong angle mode and you just don't pick that up. Like on my calculator, when I'm in degrees mode, there's a tiny little D up the top, like tiny. I don't even know if I could get this to the camera in a way that you could see. Look how small it is there. And it just moves over to being a tiny little R beside it when it's in radian mode. So it's really easy to not notice what mode that you are in. So some students take 2 calculators into their HSC, and one of their calculators they set to degrees, and one of them they set to radians, and then they use each calculator for what particular application they are doing. I didn't do that. I just switched between the 2. I'm not sure what the best method is in terms of that is, but it has worked for some students in the past. If that's what you want to use, then that's an option for you. You are allowed to take 2 calculators into the HSC. So what does the error look like? So say I have degrees on my calculator and I say, hey, what does tan pi on 3 look like? We don't need an equals symbol there. We just need that. And I get this answer, 0.018. Okay, now what did we say the answer was? We said the answer was root 3. 0.018 is definitely not root 3. Root 3 is going to be like 1.8 or something like that. So this is not even close. But if I change my calculator to radian mode, it's 1.73. A completely different answer. So, short story is, you can use your calculator. Long story is, convert between radians and degrees, keep the exact value triangles in your mind, make sure you're using the right calculation when you're doing it, make those conversions, use exact values, and so on and so forth. But obviously you're going to use your calculator. You need to make sure it's in degrees or radian modes, or you'll make a mistake. Now, some new calculators won't give an answer like this, 1.3732. Some will actually give the answer as a surd, as an exact value, which is excellent because you can just write that down. If you are using a calculator like mine, the answer is in decimals. You could square it and see if it's a surd. Otherwise, you would have to remember what the exact values are, which is what I did when I did my HSC, and I did these sorts of solutions the way I showed you the long way to make sure that I was getting them correct. Okay, so what's the moral of this whole story? Use your calculator, make sure it's in the right mode. You will get the right answer, but make sure that when you get the answer, you just have a checking mechanism. I always talk about students, hey, graph something, draw something, write something that allows you to have a checking mechanism so that if your calculator spits back out 0.018, your brain will be like, that makes no sense at all. And then you'll be like, what's going on? What's wrong here? And you'll realize, oh, that's right, I'm in the wrong mode. So hopefully that clears up what radians are and how to use them in trig ratios for you.